This
Do you guys
conference
have
will
any
now
questions
be
for me?
recorded.
Okay, if no questions, let's talk about another new data set, or I can say data structure, which is set. Set is a type of data structure which is completely opposite to our list. The list has the index and it maintains the insertion order, and it allows the duplicates, and it also allows the nulls, right? But set is mainly meant for uniqueness. When you want unique objects, when you want to play with unique objects, we'll go with the set. It does not have index, it does not maintain the insertion order, and it will not allow the duplicates. Okay. uh, Coming to the null, but there are different kind of sets in uh, this under set trait. There are different set classes are there, like a tree set, hash set, and linked hash set. The tree set will not allow the null. Tree set is ordered one. Order. It's not insertion order. It is as it's ascending order. And other two sets will allow the nulls. Okay, let's see first the basic set operation and what is a set and how it will work, and we'll see. Then we'll move on to one by one. Okay, let's look at here names. I'm, I created a set. Let's start. Okay, look at here. Um, let's see. Earlier there was a doubt while creating a set. We have to give only the hard-coded values, or we can pass the variables. Yes, you can pass the variables. Okay. So look at here. I have a first name and last name. Even not only list it for even the set, or even for map, if you have a variables, you can pass the variables. Okay, so look at here. I have a first name and I have a second name, and I'm giving as a arguments. Okay, if you look at this is my set. Let me create it and look at the order. It's a Java, HDFS, MapReduce, Hive, Scala. This is the order, and let's look at one after creating a set. Okay, before that I need to create a first name and second name. Now look at here, guys. So the order which I have given is Java, HDFS, MapReduce, Hive, that order. But if you see the order, it's a different order. And also if you observe closely, it has removed the duplicates. MapReduce twice, it removed, and Animation is twice and it removed. I mean, it made it only once. And also if you observe closely, there is no order. There is no insertion order. And if you try to get like this, if you try to get like this, there is no index here. There is no index. Okay, let's look at here. It says that when you pass an element in parenthesis, it will say whether it exists or not. It will say whether it exists or not. Okay, so what it does, removes the duplicates. It will not allow the duplicates, and also it will not maintain the order, and also it will not be having index. Okay, so if you want to, these are all very much common methods which we have seen earlier. If you want, you can try once again. The first one is head, the second one is last, the tail is come apart from the head, so whatever is there, there's a tail. We have a size, and we're checking whether it's empty or not. And if you see uh, from this diagram, look at here: set, has set, list set, and a tree set. These are the three classes. And has set and list set, the has set and list set will allow the null, but a tree set will not allow the null. Remember one thing, guys: wherever you see tree, tree, look at here, there are tree map and tree set. Wherever you see tree, it means it is a sorting order. It is a sorting. It is a sorted. That's the reason their parent is sorted. Sorted map, sorted set. Wherever you see tree, it means it is a order one. Okay. So in other languages like Java and other programming languages, if you see linked list, linked, there are something like, it's actually has set, linked has set, linked has set. It's a uh, hash map and linked hash map. It is a linked hash map. So wherever you see linked, the meaning is um, when you have a linking, right? The insertion and deletion is faster. Insertion and deletion is faster. Okay, I'll show you one more. What I can say the examples for that. Hash set. Wherever you see hash, set, or hash is nothing but hash code. The name came from the hash code. It actually maintains the uniqueness. Hash map, hash set. Okay, they are actually meant for uniqueness. Linked hash set, list set, tree set. Set by default is the uniqueness. So, okay, you may ask a question. So, how it maintain uniqueness? Any guesses? How the set maintains the uniqueness? How set maintains the uniqueness? Anyone?
Through hash map.
Not hash map. Internally, it uses the hash code and equals. Internally, it uses hash code and equals. Look at here. Your set it actually internally maintains equals and hash code to check whether the already existing element is there or not. To maintain uniqueness, it internally uses the hash code and equals. second. Contains size, contains the plus, the minus, iterator. It is not showing here, but internally it has a hash code and equals for maintaining the uniqueness. For example, I can show you that example. Okay. Um, Look at here. I have a employee object. Try to remember, guys. It is a internally to actually maintain the hash code and equals, right? With the help of the hash code and equals contract, it will understand whether it's a new object or an existing object, right? Look at here closely. I'm creating a class. I'll be proving that it internally uses the hash code and equals. Okay. Look at here. I have created a class called set employee. I mean employees. So there are a lot of employees created. So it was giving error. So that's the reason I given the set employee with the name, age, and ID, salary. Okay. So what I'm doing here, um, equals method, equals method, and a hash code method I have overridden. I have overridden. So after overridden, this is the code internally it has. Okay. Now look at here. I'm going to create some objects for set employee, like a Ravi object, Veera object, like that. Okay, let's see. Look at here. First, okay, let me do one thing. I'll show you in the console. I'll show you in the console. It's a class defined. Look at here. I'm going to create two objects. The name is Ravi, age is 34, roll number and salary. Okay. I'm going to create two objects. I'm going to create two objects. I have created two objects. Now I'm going to put these objects into the set. I'm going to put into the set. Look at here. How many objects it loaded? Only one object or two objects? Internally it
Only
loaded
one,
one object or two. Why only one?
because the values are same.
The values are same. Name is same, age is same, roll number is same, employee ID is same. Correct? It means internally it uses the hash code and equals, right? Ravi dot hash code, Veera dot hash code. Okay, Ravi dot hash code and Veera dot hash code. And look at here, Ravi, true. Both are same. The instances you cannot compare. Instances are different. Ravi instance is different, Veera instance is different, but the content is same. The content is same. So let me show you the same example other way. I will go ahead and comment these two methods. I will go ahead and comment these two methods. Okay. I will go ahead and execute this. Classes define. I'm going to create two objects again. It's all fresh setup. Freshly, I'm going to execute. Ravi object is created, collection also created. The collection is means set collection. Look at how many objects is loaded in the set. How many objects is created in the set? Look at here, guys, closely. 1, 2. Because Ravi and Veera. It's a Ravi hash code. It's a Veera hash code. Okay. Okay. So, since if you didn't overwrite your own hash code and equals, it is considering them as a two different objects. Is this clear? Any confusion?
Ravi,
Rishabh,
can you repeat it once
Shankar?
again?
Yeah, Ravi, can you please repeat it again?
Okay. I have commented the equals and hash code, right? Earlier, look at here. I have written my own class. I have written my own class with the name, age, ID, salary. Okay? Name, age, ID, salary. Name, age, ID, salary. And I have a equals and hash code methods. The purpose of the hash code is to create a hash code for your object, whatever the object you are going to create. The purpose of the equal method is to compare two objects whether they are equal or not. You guys aware of this hash code and equals? Yes or no?
Yeah, yeah, yes.
The hash code helps you. Look at the method. Hash code returns integer type. Equals tells whether same or not. Two objects are equal or not. Okay. The purpose of the hash code and equals are to check whether both the with the help of the both the methods we can clarify that whether two objects are exactly equal or not. Exactly equal. When I say exactly equal, content should be equal, objects should be equal, their hash code also should be equal. So what I did, I created two objects. One is Ravi, val Ravi equal to new set employee, Ravi 34, some number, some salary. Similarly, I created Veera. Similarly, I created Veera and Ravi 34, some number and this. So if you look at here, what is happening? These are two objects, right? But the content is same. Both the objects content is same. Who will tell whether these two content same is or not? Your hash code and equals. Your hash code and equals. So that's the reason if I print Ravi hash code and Veera hash code, both are same. And when I compare the content of the Ravi and Veera, both are same. How it is possible, how it is able to do it? Because I have overridden my own equals and hash code. Is this clear till this point? If not, I'll repeat again.
Yeah,
It is
Ravi, it's
clear
clear
till
till
this
this
point.
point. Yeah, yeah, yeah.
So if you have your own hash code and equals in your class, it works perfectly. It tells the objects you are going to create for the class is equal or not based on the hash code and content. Now I have removed, I have commented, removed is nothing but I have commented. I have taken out the hash code and equals. I didn't override because hash code and equals is by default, it will be there. Hash code and equals is by default, it will be there for every object. But that's a different implementation. That is not your own implementation. Look at here. While I'm doing equals, I'm checking for my object name, age, ID, salary. But default equals is different. Default hash code is different. Okay. Now look at here. After that, I created
So,
two objects. Please go ahead.
Ravi, after completing this, can you please explain this override def equals code? What is this that dot?
It's a very simple
Yeah,
one.
this
No,
this piece.
already you are comparing the content. That
So,
see, okay, okay. See, this means current object. That means the object which you have passed. You are not passing here, but when you're when you're internally checking whether they both are same or not, two objects is required.
yeah, yeah.
Two, two objects is required. That that represent the other object. This represent the
Okay,
current object.
okay.
Okay, so you can look at here. Can equal. Okay, it just an instance. It tells that other object, nothing else. And also, you really no need to write this one. You can generate this code. Let me repeat. Let me show you how to generate this code. You are not going to write this. You will be generating this code. Look at here. Equals and hash code. You just need to select what are the variables. What are the variables? It will get generated. It will get generated automatically. You are not going to write them. It will write. It will generate behalf of you by your IDE. Not only hash code and equals. Not only hash code and equals. You can actually generate other some methods like toString, companion object. These things you can generate. Okay, right click, generate. Setters and getters also will be generated in similar way. Okay, okay. Let me do. You really not to worry about the logic how you write. You can or else you can simply. It is very simple logic. You are writing a case statement, pattern matching. If you remember, uh, pattern match. We discussed the very initial days of Scala. So others match case that that is I have taken a variable here, right? That this is the that okay, that is nothing but the object which I'm passing, and that can equal this. And see, it should be all these conditions should be satisfied. Name should be equal, age should be equal, ID should be equal, salary should be equal. Then only we will say it is equal. It's a it's a simple, what I can say, simple logic. You are checking, you are passing two
Yeah.
objects, current object and other object, and you are comparing them. Nothing else. See this side, whatever you see, e name, e age, eid, salary. These are current object. That is nothing but here you are getting no case. In the case you are getting, right, that's the that. The case you are declaring, no, that one. other object. Hash code also same. Look at here, sequence of these elements, and you are creating a hash code for every element, and fold left you are using here. Why 31? 31 is one of the prime number. So hash code internally uses that it will take one prime number and it multiplies by the every element. Okay, every element means every element's hash code. Every element's a hash code. Look at here, this is the hash code. Okay, then with the
Okay.
help of those two methods, you are making sure that whether the two objects are equal or not. If you don't overwrite your own equals and hash code, it will not consider, even though if you created a two equal objects, it will not consider they are equal. Look at here, set of Ravi 34 and this set of this, so both are equal, still it is considered as a two different. And also you can see the hash codes, the different hash codes has been generated. Different hash codes has been generated. Okay,
Yeah, bro.
okay, so your hash set or hash map will internally use hash code and equals for comparing the objects. Okay, to get the uniqueness, even these are strings. Sir, okay, sir, you have created your employee class. That's the reason you have written your own. What about the strings and numbers, sir? If you take any string and number, by default hash code and equals will be there. Let me show you an example. This is string class. Okay, equals. Look at here, your string class equals method. Okay, similarly, let me show you hash code also. Hash code. Internally hash code will be there. So 31. It's a Java code. Okay, don't get confused. This is Java code because strings, the Scala uses Java's library. That's the reason it's showing in from Java. Okay, so not only string, guys, not only string. Let me take. These are all from the Java language, like your class and other parts. You can see. Okay, let me show you. Not only strings. mm, Int. Okay, let me show you int. Did I define anywhere int? No problem. I'll type here and I'll just do that. Int. Why it is not showing? By default, it will be there. It's not a class, it's object. It's a class, right? Int class. Not sure why it is not there here. I'll do one thing. Let me show you. If you take an integer class equals, this is in Java, guys. So because of that, I compared and said Java integer is the int, okay, and there is something called hash code. So what I'm trying to show, okay, the reason behind is bringing this. One second, let me remove this. Internally every class, every object will have their hash code and equals. Their hash code and equals will be there. But until unless you overwrite whatever you require for your program, so whatever you require, whatever you overwrite for how it is, the way you require for your program, it will not take, it will not compare. If it is a custom, if it is a default like a string and all, they have their own implementation, they will work. Any doubts so far? Any doubts so far? Any doubts? I hope rest all you guys are very much clear, head, tail, all these methods. Okay, and the same methods only what we have seen in the other session, like a list. Suppose if you want to do like this, you can do. Okay, let me show you. You have names and you have a course. Okay, and the course size and contains you can check, and adding the elements to the set course plus pick, course plus equal to something, course plus, and then the array, course plus another collection. This is a tuple, we'll call as a tuple, another collection. You can add like this. Suppose if you want to take a mutable set, you can take a mutable set. So whenever you want to make use of mutable set, as I explained you earlier, you have to use this package. This package. Okay. So here, this is the mutable one. Okay. Even mutable set also will not allow the duplicates. Even mutable set also will not allow the duplicates. Okay. And if you want to add element, if you want to add with the help of the add method, if you want to remove, if you want to remove group of elements, if you want to remove complete list, you can also use the remove method. Okay. So these are the different options available in the set. And this is we have already seen with the minus. Filter also you can apply, map also you can apply, all other methods also you can apply, whatever we discussed earlier. All the methods are applied because this is also collection. Yesterday whatever we have seen, that's also collection, this is also collection. But the difference is that collection allows the duplicates, that collection has index, that collection has the list collection I'm talking about. Coming to the set collection, it's different. And when it comes to the set, internally they have different sets, right? Internally they have a different sets. Has set. Okay, let me show you that. Has set. All the methods are same, guys. Look at here. Has set. It is asking me to import that has set. Let me import it. Import. You can say underscore It means all will get imported. Under that package, all will get imported. Look at here, the hash set, there is no order. So whatever you have given is a different order, there is no order, there is no duplicates. It removed. Set is the parent, hash set is the child. Okay. There is something called list set also, right? Look at the difference. Look at the list set. List. Whenever you see a list, insertion order will be there. Linked list. I told you, right? Linked list. Insertion order will be there. Look at the insertion order and remove the duplicates. Let's try to remember very logically. If you look at the hash, it means uniqueness. Set is by default unique. List is by default, it allows a duplicate, it has index, it insertion order and all. That's a high level. List, set, they're high level. But whenever you see tree set, tree map, whenever you see tree, it means sorting order because its parents are sorted. Tree set parent is sorted set. Tree map parent is sorted map. Right? Wherever you see list or a linked list, wherever you see a list or a linked list, insertion order will be there. Insertion order will be there. That it can be a list, it can be list set, it can be list map. Insertion order will be there. Try to remember this the behaviors by names. Wherever you see a hash, they'll maintain uniqueness. Rest all is same, guys. Rest all methods are same. Look at here. The hash set, list set. You see the difference. The same only same values I have given for the hash set. For the same values I have given for list set. See the difference. Same values I'll give for the tree set, but this time I'll give some what I can say jumbled. I don't want to give the sequence. I'll give the different. Let me give you like this. Duplicates. I want to give duplicates also. Look at here. This is it. I'm not okay. Same example. Let me show you with the list set. It will maintain the insertion order. Look at here 34, 2, 31, 56, 23, 12, 55. And it removed the duplicate. 31 came twice, so it's taken out. Okay. Now the same thing I'm going to give with the tree set. Tree set. Look at here. Sorting order. Sorting order. So that's the difference between those classes. You may ask, so what is the difference between the hash set, list set, and tree set? Hash set is nothing but a set. Hash set is it maintains uniqueness. It will not have the order. It'll allow the null. If you want to see the hash set, it'll allow the null. It allows the nulls. Even list set also will allow the null. List set also will allow the null, but tree set will not. But tree set will not. But tree set will not allow. Any doubt about the set? Any doubt about the set? Any questions? We have seen a set, hash set, list set, tree set. Not only numbers, you can give employee object or customer object or whatever the object, you can give those objects. But make sure that this is the most important entry question. Make sure that whenever you are giving your custom objects, Whenever you're giving your custom object means our own objects like employee class or customer class or animal or whatever you're giving, make sure that you have to override equals and hash code because they maintain uniqueness. They maintain uniqueness. For the list is not required. For the list, you really no need to write hash code and equals. For the list, it is not required because they are not maintaining uniqueness. Whoever maintains the uniqueness, you have to give. You have to give your um, what I can say equals and hash code. You should overwrite. Is this clear? Is this clear? Yes, no. Everything
Yeah,
is same. Your traversing and everything is same. Contains whatever we have seen in the last session. All are same. You can apply your map. You can apply filter. You can apply flat map. You can apply distinct. All these things. Anyway, by default, it gives you the distinct. Okay. So let me copy this also. Go through this once again. Go through this set class once again. Try to understand. People will ask an interview what is the difference between the list and set. You can expect
Ravi,
more,
I have one question.
please.
I wanted to understand, like we have multiple collection like list, set, and tuple. So,
Hmm.
in what all cases, in real time, in what all cases I can use on what situation?
That's what see by definition itself is telling you that what cases you can use. Suppose you want to load the elements, you want to load the objects into a collection which maintain the uniqueness. So which collection will go? You want to
Uh,
maintain the uniqueness. You
Set.
want to maintain the uniqueness. Set means set is see what we need to understand one thing. The set is a high level trait. Inside the set, we either will go with a hash set, tree set, or list set. Correct? Set
Okay.
is the high level. See, for to make you understand, I have created a set. Yes, here it allows you can create a set, but internally, either you go with a hash set or a list set or a tree set. Let me give you a scenario. You are getting an objects and you are adding into one collection. You want to maintain you want to maintain uniqueness and you want to maintain sorting order. Which collection you'll use? Which collection class you'll use? Remember, you want to maintain uniqueness, you want to maintain uniqueness, you want to maintain sorting order, and you want to maintain you should not allow the null. Which collection class will go with it? Which collection class will go with?
Sorted set.
That's what tree set. You'll go with the tree set, correct? Tree
Yeah.
set is a chain.
Okay.
So these are all traits. You cannot create objects for them. You cannot create objects for them. You can just have the references. The these are the classes. Tree set. We'll go with the tree set, correct?
Yeah.
And let me give you one scenario. And you want to load all the objects whatever it comes. You want to load all the objects whatever it comes. You are not going to worry about the uniqueness. You are not going to worry about the null. But you want to maintain the insertion order. And you want the index. Which collection will you use?
Linear SEQ
Yes.
list.
Yes. In the linear sequence, you'll go with the list. Correct?
Yeah.
That's how it works. So
Okay.
based on your requirement, you will choose whether I need to choose a hash set or a list set. You tell me, and you are getting the objects, and you want to maintain the uniqueness. and you want to maintain the insertion order. You want uniqueness and insertion order, not the ascending order. You want to maintain the uniqueness and insertion order. Which collection class you will use?
Hash set.
List set. Hash set will not maintain the initiation order. No.
Okay,
Hash
sorry.
set will not maintain the initiation order. Look at here. 1, 2, 3, 4, 5, 6 I have given. And it given the randomly. But list set, look at here. List set. 34 to 31 I have given one order. The same order only it has given. List set. List means it will maintain the insertion order. You're getting my point, what I'm trying to show?
Yes, yes, I'm getting.
Okay, so that is how you'll decide which class need to be used. So we'll talk about the map. We'll talk about the map in the coming sessions. But tomorrow I want to start with the Spark map. Anyway, I'll cover. It's also one type of data structure, key value pair, and also it's important. We'll discuss about in the coming. But tomorrow we'll be starting Spark. Okay, if it's possible, you guys can install Spark in your environment. It can be Windows environment. Uh, it can be uh, what I can say. Any of the uh, uh, Ubuntu or the Mac or whatever it is. Okay. Any questions? Any questions?
No question.
Okay. So uh, try to remember this this one, and you really no need to remember all these classes or all these iterator, not iterator. What do you call traits? Hash set, list set, tree set, hash map, list map, tree map will cover these three, and a list. Stack, stream, queue, and all we really are not going to use. Okay, so most of them will use like this only. Hash set, reset, these things, and these three, and a list. These are all we're going to cross verify. Okay, and also they have a mutable as well as immutable. You need to remember two things. You have a mutable as well as immutable. Mutable and immutable. So look at here. This is a let me size. Okay. In the set, you have a hash set, linked hash set, from the immutable, mutable. Okay, and sorted set. It's a byte set. Look at your map, hash map, open hash map, weak hash map, linked hash map, list map, tree map, immutable map adapter. There are a lot of things. This is mutable. Mutable has more. And also when it comes to the linear sequence, look at how many childs are there. Linked list, array sequence, array buffer, string buffer, list builder, list buffer. So these are all immutable one. The above one is immutable. This one is mutable. Okay. So try to remember in Scala two type of collections are there, mutable as well as immutable. Okay. So try more hands-on because people concentrate more on the collections only in interview. Okay. Okay. Let's start tomorrow. We'll be starting Spark. I'll be showing you what is Spark, how it will work and all. Any questions, please stay back and ask me, else we can leave for the day.
No questions, Ravi. Thanks.
Thank you guys. Thanks for your time. Have a wonderful day.
Thank you, Ravi.